Okay, so for our second video that's part of that prerequisite chapter, we did a little bit of stuff with exponents, and I know that there was a time we worked on that, and that was actually very difficult for a lot of us. So we started off with this little question here where we have the numerator that is being raised to the -2 power. You want to remember that a -2 power actually means not only are we going to square it, but we're also going to flip all those answers over. So this says take 3 and square it, but put the 9 on the bottom. And also you want to remember that powers of powers multiply. So what I did right here in my work is notice, I'm just going to take this one piece at a time. X to the -4 to the -2, I multiplied those together and I got 8. 5 times -2 is -10. I did square the 3, but because it has that negative exponent, I moved it to the bottom. And then down here again, powers of powers multiply. So 4 times 3 is 12. -2 times 3 is -6. And then the last little piece is remember that negative exponents are by definition reciprocals. So the 10 y's that are here really belong on the bottom and the 6 y's belong on the top. So if there's 6 y's on the top and 10 on the bottom, there's really only 4 left when we subtract those exponents, and similarly with this. Now, number 7, when we move a little bit deeper, we have a problem that has been written in standard form, which a lot of people don't like. And so what we wanted to do is to go ahead and find the slope of that thing. So if you want to get the slope, what we really would like to do is get mx plus b. So in step 1, I decided to move the 3x to the other side. My goal, of course, is to get y by itself. So it looks like y equals mx plus b, but I still have that -2 there. So I'm going to divide every single piece by -2, being very fair as I come across the line. You can come in, Ashley, you're fine. And then that's going to leave me right there with the slope. Now, I could have kept going and actually put it in slope-intercept form, but I chose not to because the problem didn't actually ask for that. It just says, what's the slope? So I stopped there. Now, when we look for the slope of this one, it again was set up kind of inappropriately. So I decided to again isolate y. I moved the x to the other side. So 3x plus 4 is 4y. I divided everything by 4, and you could see right there that my slope is 3/4. Now underneath, if we're going to find one that is parallel to this line, if lines are parallel, what you want to remember is that parallel lines always have the same slope. And so since I want a slope, and we just found out that the slope of this line right here was 3/2, I want a slope of 3/2 in that point. So what I did is I used the point slope form. So my slope was 3/2, and it went through +5, -2. And over here, we wanted, again, the perpendicular slope. And what you want to remember is that perpendicular slopes are opposite and reciprocal slopes. So if I wanted -4/3, then I would use 3/4 would be -4/3. There's my slope, and there's my point. And the last question, I believe, in that review for that unit is taking a look through a series of problems and deciding which one is linear, which one is exponential, or in fact, none of the above. So when I look at this little set right here, what I noticed is as a pattern, W is growing by 2's each time. Well, that's kind of nice, but not perfect. And then I saw that it grew by 10, and then it grew by 18, and then it grew by 26. That's not a particularly great pattern. So maybe it's a multiplication. Did I multiply by something? Well, 6 times 4 is 24, and 24 times 4 is, well, that's not 50, so I'm thinking maybe not. So, if I'm looking for linear or exponential, linear problems always have a constant addition or subtraction involved. Exponentials have a constant ratio, which is like a constant multiplication or division involved. So I'm thinking that this one just doesn't have it. So let's go back here, and there's a little bit of a hint. I don't know about 384, but I can see that if I divided by 4, or in other words, multiplied 24 by 1/4, I got 6. And it turns out 96 times 1/4 is 24. Oh, so it does look like in y equals a times b to the x, which is how an exponential looks, it does appear that I am always multiplying by 1/4. So we've got some kind of a constant times 1/4 to the x power. And my initial value, what happens when I plug in 0, was 384. And so that is, in fact, my exponential portion of the curve. Now, I'm pretty sure that the second portion, we're just going to leave it alone. But in the third one, I notice that we're always going down by 3s. So my delta W, which is kind of like delta Y, is I'm losing 3. But my delta N up top is always growing by 2. So it looks like I've got a slope of -3/2. So if we just take it a little bit further, I guess one thing that I could do is I could just use point slope maybe if I wanted to, and I could say the W value minus 19 is equal to the slope times the x value minus the value that kind of goes with that 19. Now, that's not the only way to do it. I know that a lot of people would choose to distribute this out and then maybe add that 19 to the other side. In fact, I'm going to look at how I did this problem in the past. Notice as I came through this, I did get that same answer that I had. I noticed that it was not a constant ratio or a difference, so that wasn't good. So let's see what I did last year when I solved this problem last time. Is I did notice the line because it was a constant rate of change. So I figured out that the m was -3/2, which I showed, and I just kind of went to y equals mx plus b and figured out that the b value had to be 47/2. So that's the end of the prerequisite chapter videos. I hope that that was helpful. I'll see you again for chapter 1.